The problem I did is homework 2, number 17. And in this homework, you know that in this problem, you know that the frequency is 27.5 Hz. The entire length of the string is 2 meters. Mass is 400 grams. Is equal to 0.4 kilogram. And also the vibrating section of the string is, I say is LV in this problem is 1.9 meter. This is the known part. And what we need to find is tension. So we need to find the equation of tension for now. So the equation related to tension is velocity equal to square root of tension over mu. From this equation, we can get tension equal to v squared times velocity squared times mu. And we know the equation of mu, and we know the equation of velocity. So for mu, the equation is mass over length. And the equation for velocity is v equal lambda, which is wavelength, times frequency. Okay, I will solve mu first, then I will solve the velocity later. So mu is equal to mass over length, which is m over the entire length, which is 0.4, you know, from here. And length is 2 kilograms per meter from here. So in this situation, the result for this mu is 0.2 kilogram per meter. Then we will find the velocity. In this problem, you know the vibrating section is 1.9. So vibrating section of the string, we say is this length maybe. So I will say it is 1.9 meter. And we know it's vibrating. So it should be like vibrate like this. Maybe. So it's well like vibrating. And we know lambda is the section. Lambda is the wavelength. So the wavelength is a whole cycle. This is will be a wavelength. So 1.9 meter, which is the length of vibrating, which also is 1.2. 1 is 1/2 lambda. So we can say lambda is equal to 2 LV. Then we put this one in this equation. So we can know velocity was equal to 2 LV times frequency, which is 2 times 1.9 times 27.5 Hertz. Okay, and we can get it. The number is 1.4.5 meter per second for velocity. Now we know the mu, which is 0.2. We know the velocity, which is 104.5. Then we can put them in this equation in tension equation, which will let us find tension equal to 104.5 squared, which is velocity squared, times 0.2, which is mu. So the answer will be 2184.05 Newton, which is, we can round it to 2180 Newton.